All right, so we are starting out today reviewing the topics we looked at last week, all of our different factoring techniques, as well as some foiling and multiplying patterns. So our first example here is just a basic foiling process. We have 3x squared times 2x squared, which gives us 6x to the fourth. What about insides and outsides? Will those be like terms that we can add together? Okay, so outside gives us negative 15, and inside 14. So we end up with a total of negative 1x squared. And last term? Yes, negative 35. All right. Second question, these are conjugates, right? They look almost identical except opposite signs. So what happens when we FOIL those? Yes, middles drop out. We end up with 9x squared minus 16. Okay. The next two were the patterns that we looked at last week. What do we do when we want to square a binomial? Okay, our first one here is a binomial, two terms. What do we do when we want to square it? What is it? First term squared, so 5x gets squared. Okay, then what? Okay, double the product. So the product would be 10x, doubled would be 20x, and last term, we square it. 2 squared would be 4. Okay, so it's the first term squared, twice the product, and then the last term squared. Okay, that was the pattern. We have a similar pattern for cubes, a little bit longer, but just like we had 2's here, here, and here, we're going to have 3's in those places for the cubes. Okay, so we have something cubed plus 3 times its squared, and then to the first power for the second term. Then we have 3 times first term, second term squared, and last we have second term cubed. Okay, how many remembered that pattern today? Good. How many had to look it up? That should be the rest of you, right? You either remembered it or you had to look it up. Okay. Keep in mind, I'm going to be looking for this pattern when you take your test. All right, dumping our numbers in. First term is a 3x. I put that in the first position in the first 3 terms. And then the second term is a negative 5. That goes in the other 3 spots. And then I have to figure out what my 4 terms for my answer would be. What do I get here? Good. Okay. Number 4, sorry, second term here in number 4. Which part do we do first? Yes, square it. So the 3x gets squared and becomes 9x squared. Okay, 9 times 3 is 27 times negative 5. Good. All right, third term, we square the negative 5 to get 25. 9 times 25 is, I think, 9/4. 225. And we just have a single x on that one. And then the negative 5 gets cubed to be negative 125. Questions on that? All right. How about this one? It's another square pattern, but a little more involved. We square the first term, which turns into what? Okay. We take the product and double it. So the product would get me a negative 6 of them. Doubled would be negative 12 of the x squared y squareds. And then the negative 3 gets squared to become a 9. Questions on any of that? Okay, so make sure you know how to FOIL. Make sure you know how to do the squaring pattern here. and the cubing pattern here. Okay. Last week we also looked at subtracting and adding polynomials that had multiple variables. First step is to make sure you distribute that negative sign, right? Because we tend to forget about it when we get to those second terms. So we've got x cubed y squared minus 3x squared y plus 4y minus 6x cubed y squared positive 2x squared y and then a negative 8y. Okay, so I've distributed the negative, then we look for like terms. I can combine those two because the variable parts are the same. How many do we end up with? Okay, so we have negative 5x cubed y squareds. I can combine this piece and that piece to get negative 1x squared y. And then I can put my y pieces together to have negative 4y. Questions on that process? Okay. The last 4 questions on the review portion were to help you review all the different factoring techniques that we looked at last week. First one's a basic trinomial. What did you factor it into? Okay, agree, disagree? X minus 1 and x minus 8? Does it work? Okay. Second one here has 4 pieces. Now there's 2 ways you might have gone about this one. Some of you might have looked at it and said there's 4 terms, which means I use grouping. Okay, so you could look at it that way. If we were to solve this one by grouping, or factor this one by grouping, the first 2 terms have a common x. If I factor that x out, I have x minus 4 left. In the second 2, I can factor out a common 3, and I still have the x minus 4 left. And then because both parts have an x minus 4 in common, it's like that GCF that we can pull out. So I'm going to pull out the x minus 4 piece. What I have left over is the x from there and the plus 3 from there. Okay, so that's one way you could have solved this one or factored this one. Anybody look at it differently? Okay, so she said she added these 2 terms together, which you certainly could do. All right, they purposely kind of split it apart so that you could think about it in terms of that grouping and review that pattern, but you certainly could add those together. You'd end up with x squared minus x minus 12, which would still factor to the same thing. Okay, so either one was okay. Question 9 only has 2 terms. This is one of our special patterns. What do we call this? Difference of squares, yes. So the root of this would be 10x. When we have a difference of squares, we're going to have conjugate answers, okay? So 10x in each one. To get the negative 49, what do we need to do? Minus 7 plus 7, yeah? All right, that was called that difference of squares. How about 10? It's one of our special patterns. It is a trinomial, so you can look at it just in terms of factoring a trinomial, but it's a special one. What do we call it? Perfect square trinomial? Because the first and last terms are perfect squares, and the middle works out nicely so that our 2 factors are identical. All right, so x squared becomes x times x. The 25 is 5 times 5. We need a negative in the middle, which means we need 2 negatives to get the negative 10 in the middle and the positive 25. Remember, these can be written like this, as x minus 5 quantity squared. Okay, I would accept either answer. Okay, so take a second and think about how did you do on this review page. If there were things that you needed to look up, you might want to make a little notation in your in the margins so that you can study that topic a little more. We just have one new pattern today. We did a review where we took a plus b and cubed it, right? That's the big long pattern. Okay? That's not the same thing that we're looking at today. This says I have a binomial that's being cubed. Okay? This says I have a perfect cube plus a perfect cube. So the sum of two cubes, or in this case, the difference of two cubes. All right? It's a different idea. They all have cubes in, so students often get them mixed up. Okay? But remember, this means we're expanding it so that we have three of them, right? And that's why we have that shortcut pattern, because expanding it out and multiplying all that together takes a long time. Okay? The patterns here are almost identical for both of these. Take a second and listen before you write. Here we have a cubed plus b cubed, and notice our first factor is a plus b. So we're really just saying, what are the roots? What are the cube roots of each term? What is it that was being cubed? Okay. Here we have the difference of two, and our first term is a minus b. Okay. So the sign that you're going to have in the first factor is going to match what you started with. Okay. In the second piece, there's a trinomial. We take the first term and square it. We find the product of the two, and then we square the second term. And it's the same thing here. First term squared, product of the two, second term squared. I remember it as there's only one negative sign in the whole thing. So if I use up my negative here, everything else is positive. If I use up, or if I start here with a positive sign, my next number is going to have to be that negative piece. Okay? Your last term is always going to be a positive, because anytime you square something, it's going to come out positive. Okay? So the trick to doing these is to recognize that you have two perfect cubes that are either being added or subtracted, and then you have to find their roots. Okay? So for our first one, we have an x that's being cubed, and we have a 3 that's being cubed, right? 27 is the same as 3 cubed. So this is the sum of two cubes. Our pattern says the first term's a binomial, and it's just the roots. Okay? So the root of that would be x. The root of the 27 is 3. We had a plus sign in between, so we keep that. Then the second factor is going to be a trinomial. We take the first term, which in this case is an x, and square it. We take the product of them, so 3 times x, and we square the last term. 3 squared would be 9. Anytime you square a number, it's going to come out as a positive. Our middle sign here is opposite of the first sign. So we started with a plus sign, we're going to have a negative there. Okay? So first one squared, we have opposite sign of the product, and then the second one squared. All right. What is being cubed to turn into a 64x cubed? In other words, what's the cube root of that? Okay? So we're going to think of this as a 4x that's being cubed, and then to get the 125, a 5. Yep. All right, so we have a cube minus a cube. Difference of two cubes. The 4x and the minus 5 are going to come down as your first factor. That's the binomial part. All right, we're just looking at the roots. The second factor is the trinomial piece. We take the first term and square it. What do we get if we take 4x and square it? Good. Okay, we take the product. 4x times the negative 5 is negative 20. We need the opposite sign, so positive 20x. And then we square the negative 5, which turns into positive 25. Okay? And there is no way to factor that further. All right, the trinomial piece doesn't break down anymore. It looks like it should, but it doesn't. All right, I'm going to pause the recording for a minute. You guys try the third one there, and then we'll check it in a minute. All right, let's check. What did you get for the roots? 125x cubed would break down to 5x. Okay, the negative 8. Good. And then we square the first. So we had good. Product and opposite sign. So positive 10x. And then square the second one. Yep. Okay, so that's the new pattern that you're learning today. All right, and then we're going to kind of put it all together with what we did last week. So when you are asked to factor, there's a lot of things to think about. The first piece we always look for, is there some kind of GCF that I can take out? Okay, so that's your first question. Can I take out a GCF? Okay. Second question. If there are only 2 terms, if there's only 2 pieces to it, is it one of our special patterns? And we actually had 3 special patterns. We had difference of squares. We had sum of cubes and difference of cubes. Those were the new ones today. So anytime that you see just 2 terms, you have to decide, is it a difference of squares or a sum or difference of cubes? Because we can factor those. If it doesn't just have 2 terms, does it have 3? If it has 3, is it another special pattern? It might just be a basic trinomial. It might be one of those perfect square trinomials. So is it something that I can break down and factor? Again, either a basic trinomial or a perfect square trinomial. Okay. What do you think the next one is? We did 2 terms, we did 3 terms. Next would be 4 terms. If there are 4 terms, can we use that grouping pattern? And then the last piece, can I keep factoring? Last Friday we did several examples where we could factor it, and then we looked at our answer and said, oh, that can be factored again. All right, so our last 3, we're going to put this all together. So first question we ask ourselves, is there a GCF? What do you think for this first one? Yes, what is it? Okay, if we take the 2x out, our greatest common factor, what we have left would be an x squared plus 4x plus 4. Okay, now we look at that. It has how many terms? X squared plus 4x plus 4. 3 terms. So is it one of my special ones like the perfect square trinomials? Is it just a basic trinomial that I can factor? What do you think? It is one of our perfect square ones. What does it factor into? Okay, and because both of them are x plus 2's, right, we can write it as 2x times the quantity x plus 2 squared. All right, just so that we are recognizing that as one of our perfect square trinomials. Second example, h to the 5th minus 16h. Is there a GCF? Yes, what is it? All right, if we take an h out, what's left? Okay, now I have how many terms? 2. I look at it and say, is it a difference of 2 squares or the sum or difference of 2 cubes? What do you see? Difference of h to the 4th is not a cube. It is a square. It's the square of what? Okay, So we could factor h to the fourth down into two different h squareds. And how about the 16? Or negative 16? Good. Plus 4 minus 4. Okay. Now we look again. Have two more terms. H squared plus 4. Is it one of my special patterns? Can I factor the sum of two squares? No. All right. Can't do anything with that. Looking at the next one. H squared minus 4. That is a difference of squares again. That can be factored down. So my final answer, I have an h squared plus 4, and then this h squared minus 4 factors into h plus 2 and h minus 2. Okay? That is completely factored. All right, last one. How many terms does it have? 4. Does it have a GCF? No. But it does have 4 terms, so we can try what technique? Grouping. All right, looking at the grouping pattern, what can I take out of the first two? A 3y? All right, if I factor a 3y out, what's left? 4x squared minus 9? Okay. What can I take out of the second set? Is everybody okay with that, taking out a negative 1? If I take out a negative 1, what happens to this? Okay, my signs change. Positive 4x squared and negative 9. Now for that grouping pattern to work, all right, for us to be able to say we're going to factor by grouping, this leftover part after we took out the common pieces has to match. Do they match? Okay, so now that is a common GCF that I'm pulling out, 4x squared minus 9. What's the other piece? If I factor a 4x squared minus 9 out, I have a 3y minus 1 left. Okay. Now I look at it again. Is there anything that can be factored more? Okay, 4x squared minus 9 is another difference of squares. What does it break down into? Good. The 3y minus 1 is a two-term piece, but it's not one of my patterns, right? It's not squares or cubes, so it just stays. Okay? So the only really new pattern is that sum and difference of cubes idea. All right? All right, so assignment's going to be on starting on page 74. You're going to do 57 to 89 odds, but you can skip question 85.